G'day, it's Dan and Goran from Certified Energy Solutions here today for the third video in our mini series, where basically we're going to go over the process from the previous video where we do a load profile and system design, or energy usage profile for the specific customer, and then we now bring it into the next stage internally, which is designing a complete turnkey off-grid package based on the data collected. So I'll let Goran take over with this process here so we can explain how we come to the conclusion of whatever we think might fit your needs best.
Yeah. Now, as you can see on this screen here now, this is from previous video we made. We have a summary of the expected energy usage, winter and summer, daytime and nighttime. We have also identified the peak sun hours in that specific location. And as you can see, 3.89 in the winter and 5.69. So of course, winter is the worst period of the year for solar panel performance generation. Now, this information, we bring that into our interim sizing tool. So we have exact location. This is the 𝐏𝐚𝐫𝐿 latitude minus 26.194. We have minimum record temperature data, historical temperature data. And then we have the orientation of the panels, the pitch of the roof, what panels we're choosing. But if you go down to this section here, we have peak sun hours 3.9 and 5.7, and we have the load here. So the total load is 14 kilowatt hour a day average, and the overfill factor in this example is 270%. That means that on rainy days, overcast days, this system will still perform pretty good. Now, a recommendation of the size, in the winter you will need probably around 12.5 kilowatt solar. As you can see in the summer, it's less because we have so much more sun, UV light.
And just to kind of interrupt there, when you're looking at this, obviously zoomed in with the edit later on, when you're looking at something that hasn't mentioned on the PV, that stands for photovoltaic, which is the technical terminology for a solar panel. So just so you understand what the reference is when you're looking at that. It's fun fact for the day, guys.
So here we have populated the panels, 14 panels plus 14 panels, so that's 28 panels in this example. Further down here we have the battery sizing tool, and that's lithium. Lithium, we set the maximum depth of discharge to 80%, that's the standard. Sometimes there are lithium batteries that can have it 90%. We put in an autonomy of 1.5 days, and basically down here you can see the lithium recommended size you would need in the battery bank is between 20 and 27. So that's the interim sizing tool, and of course behind these calculations are pretty advanced calculations which
you've developed over a decade.
We've developed together with engineers over the years. So this is quite a unique tool because we take into consideration so many different factors.
And even the thing that impressed me, the information it kind of presents, once you put in all the data, you can put in the pitch of the roof that the solar panels are going to go into.
That's right.
Based on that geographical data, it'll actually tell you what the efficiency of the absorption rate of the panels are, your sunlight hours, everything calculated from that kind of background calculation. So it's pretty cool technology.
So this is the assessment together with the sizing tool, and the info sheet I'm going over to now is basically we choose the Bush-Chook system from Red Earth. We can populate the panels here. We have string configurations. We have the inverter modules. We have the battery bank. So this is basically a library of CEC approved components in off-grid. We can pick and choose different battery technologies here. Example here you can see. Now this is later on put together in the expected system performance. And this is also a copy the client gets.
So it's a presentation pack with a summary of everything that's been discussed.
So based on the peak sun hours in that location, we can see over the year, this is what's generated from the solar panels. This is the usage in the household, and we have also the numbers of kilowatt hour usage and generation. That's the factor of how much electricity are we using, but also the demand of power let's say you turn on a lot of appliances at 6 o'clock in the evening.
Yep, at the same time.
At the same time.
Yep.
This is the possible peak demand scenario. And we said, of course, possible because we can't rule that you have to have the same routines all the time.
That's right.
But this is a potential, a possible peak demand scenario, which basically is ruling the size of the inverter. Further down, we basically summarize how many panels you would need, what kind of inverter you would need, how many batteries you would need, and also once again, an acknowledgement from you as a client that yes, I understand what you have done here, and this is based on the appliances I told you we're going to use. Now, this is what we recommend. We recommend this size of the system, but many times client comes back and says, well, I have a limited budget. We can design a system based on a budget, but that means that you have to change some of their house routines, you have to use common sense.
And be aware of limitations set by the budget, because
that's right.
And that's, you know, us doing due diligence, we'll always recommend the system we advise, you know, will meet your needs without running into any issues with, you know, excessive generator run times and power cuts, things like that. So we'll always lead with that correct design first, and then if you decide that you would like to, you know, obviously change the budget, we can look at a few options and maybe change out the product for a different product that may be a little bit more cost effective, or even, you know, undersize the system, but while being 100% clear that if we do this, you can't go and turn on the microwave, the kettle at the same time, as well as having aircon, and then flush the toilet and expect the water pump not to trip the system. So you've just got to be really realistic. You do what you pay for when it comes to off-grid systems, and if it's a, you know, your forever home, you might as well do it once and do it right to start with. So once again, there's options where we might recommend you need 6 or 7 batteries, you know, to keep the cost down. You might want to start with 3 or 4 and then see how it goes. And if you can manage it with that lower battery capacity, with the option to be able to add more down the line. So there's ways around it. You've just got to have a really open, clear communication with us so we know exactly what your requirements are and what your list is, really.
And the easiest upgrade is the batteries. If you need to add more panels, that involves our installer has to go out again and install racking on the roof and panels, etc., etc. And if that is 2 years further down the track, you will get less incentive from the government. If you add another battery module, however, that's that's just half an hour job for an electrician to slot it in and turn it on.
Yeah, that's right. Awesome, mate. Well, I think we've pretty much covered that over. So, I suppose we'll bring out the next video shortly, and keep tuned and subscribe on the YouTube again.
Thank you.
On the YouTube. I sound like an old guy, don't I?